Hey everyone, I want to wrap up nomenclature of alkanes, in particular alkanes that have multiple substituents or branched substituents, branches that have their own mini branches. Let us start. What do we want to do? If you recall, or if you've been watching these videos in order, we did introduce the idea of these more complex alkanes in video was number 01B10, and we left off in that video looking at these branch substituents that have these common names. At least most professors consider them as common names. Let me draw a very long parent chain. I'll continue that in just a bit. And for instance, here we have a propyl group, 3 carbons. But if you arrange those 3 carbons as such, you get what's called an isopropyl group. And remember our tricks, or my tips. Circle it with a dotted circle, and make sure you bisect the bond. Make sure your dotted circle doesn't hit either the carbons, because that would be ambiguous, whether it's part of the parent or part of the substituent. We call this isopropyl, and I'm going to claim that this is a common name, not technically an IUPAC name, the official name. Now, for my class, if there's a molecule with an isopropyl group, if they use the term isopropyl to name that group, then for me that's perfectly fine. It's a appropriate name, it's a proper name, but technically it's not the IUPAC name. What is the IUPAC name? The IUPAC name is, they want you to consider this as obviously a substituent, but you have a branch off of the substituent. So you start, it's a little bit tiny, but you start numbering your substituent with carbon number 1, which is a carbon directly off of the parent. Okay, just so there's no confusion, this long line of carbons is the parent. There's carbon number 1 of the substituent, and here's carbon number 2 of the substituent. Well, that branch has its own mini branch, and I'm going to circle that as if it's a substituent of a substituent. That substituent is on carbon number 1. So this is a 1, and what is that in the red dotted circle? It's a methyl group. 1-methyl. Now, I have a 2-carbon chain, but I'm not going to call it ethane, because again, the A and E is reserved for the parent, whatever this parent is called, dodecane maybe, is that 12? But you reserve the A and E suffix for the parent. So it's going to look a little strange, but this is 1-methyl ethyl. And then if you have a branch substituent, you're going to set it off in the full name with parentheses. So you may have a name of a molecule that has parentheses. These two are identical to each other. Isopropyl is the same as 1-methyl ethyl. Remember the other branch substituents that I suggest you memorize from video 01B10? Well, here we have butyl, okay, 4 carbons in a row, but we could also have isobutyl. Okay, so let me draw the other two, and then I'm going to ask you to write down the common name of that substituent and the IUPAC name. Go ahead and name each substituent, each of these 3, as a common name from our previous video, and the IUPAC name. Okay, go ahead and pause the video. Alright, this one is isobutyl. I remember the isos because it's a Y at the end. Okay. This one is secbutyl, sec, SEC for secondary, dash butyl. I never explained why it's called secondary. I think that if you cover up your parent, it is attached to this 4-carbon chain via what's called a secondary carbon. So if I cover this, that carbon here is connected to two other carbons. Secondary. What's tertiary? This is tert-butyl. So what's a tertiary carbon? A carbon that's connected to three other carbons. So if I cover up the parent, the point of attachment is at this carbon here, and it's attached to three other carbons. So tertiary butyl or tert-butyl. Were you guys able to figure out the IUPAC? I need to number. I can't do this in my head. Okay, you number the longest parent chain, right? This is always carbon number 1, the one attached to the parent. So when I said parent, I meant the parent of the substituent. Okay, so that's going to definitely have a different name. The methyl group is connected on carbon number 1, carbon number 2 for the first example. And this one is a little bit trickier because now we have two substituents. We had two carbons that did not have a number and they're separate. Okay. What's a common mistake? A common mistake is that if you have these two substituents, you might circle both of them. But that doesn't make any sense because the branching is coming from this carbon right here. We have one branch to the left and one branch down here. Right? It's not an ethyl group. It's two methyl groups. Knowing that, look at your answers and see if you want to make any adjustments. Okay. If you don't want to make any adjustments, or if you had made adjustments, let me figure out what I would put. Parentheses, 2-methyl propyl, parentheses closed. Here, 1-methyl propyl. Okay, and a lot of people call this a crow's foot. Right? If I circle the full substituent of the long parent chain, that looks like a crow's foot. Tert-butyl group, and the proper, or not the proper, but the IUPAC name, official IUPAC name. Remember what we do if we have two of the same substituents? Di. You don't see that. Di. And you have to put two numbers, even if they're the same number. Dimethyl, 1,1-dimethyl, and it's on an ethyl chain. That's why I highly suggest you number the parent of the substituent, all right? Because technically you could consider this as 3 methyl groups, 1, 2, 3 methyl groups, but it's not triad methyl because this carbon is part of the quote unquote parent of the substituent. Okay. So for most classes, the professor would want you to memorize these 4 branched substituents, and you should also know how to name them in the IUPAC fashion. Let me show you an example that uses this nomenclature. 1, 2, 3, 4, 5, 6, 7, 8. Let me have 8 carbons in a row. Okay, that can't be right. 8 is an even number. So if I start out at the top, the 8th carbon has to be at the bottom. Okay. And I want to put this group 1, 2, 3, 4, 5. I want to put a Y at that carbon right here. Okay. So we have an 8-carbon chain. I'm going to double check that there's nothing longer. 1, 2, 3, 4, 5, 6, 7. Okay, so it's an 8-carbon chain. That's going to be the longest continuous carbon chain. I'm going to number it from the right to make this group on carbon number 4. So if I start from the left, 1, 2, 3, 4, it would be on carbon number 5. 1, 2, 3, 4, 5, 6, 7, 8. Circular substituent. Okay. I circled 3 carbons, but they're arranged in the Y fashion, so that's isopropyl. Because I accept the common name for the branch substituents as the proper name, I'm going to use isopropyl instead of 1-methylethyl. We'll use this in another example, though. Okay. This is 4-isopropyl octane. In the video previous to this, 01B10, I think the very, very last thing I talked about was how do you alphabetize these branch substituents. The isos you go ahead and alphabetize by the I. Okay. But if there's a hyphen after the prefix, then you alphabetize based on the root. Butyl, B, butyl, B. So you don't alphabetize based on second, third. Okay. I know it's an odd rule. That's what the IUPAC committee has decided. Let me give you a molecule similar to this, and I want you to name this on your own. It's going to be 4 carbons like that, and again I'm going to put a Y right here. Okay. Pause the video, name this molecule. Okay. If you thought that the numbering was 1, 2, 3, 4, and this is your substituent, that is actually wrong. Okay, that's actually wrong. Let me redraw this. Because we're forgetting rule number 1 of naming alkanes. You have to find the longest continuous carbon chain, and it's not 4, 1, 2, 3, 4. It's actually 1, 2, 3, 4, 5. It's a pentane. And if that's our parent chain, our substituent is not an isopropyl group. Our substituents are 2 methyl groups. And the proper name for this would be 2,3-dimethyl. Pentane. Okay. Give yourself a check if you got this name. Now, if you got this wrong, don't erase your mistakes. Right? Put an X over your mistake and then rewrite the correct answer. When you study for the exam, you want to make sure that as you look through your notes, you want to see your mistakes, because then you'll remember not to make those same mistakes on the exam. Okay? You don't want to see perfect notes, right? You do want to see your errors. Okay. All right, so that was and you could also put a little note in a different colored pen, red, and just say here that there was a numbering error. That way, on the exam, you could always pause and say, well, whoops. You could always pause and ask yourself, did I make a common error, a numbering error? Let me give you this molecule. Go ahead and pause and copy that molecule. I want 2 names. Why do I want, or how can I have 2 names? I thought IUPAC says 1 name, 1 molecule, 1 molecule, 1 name. Yeah, IUPAC. But the 2 names that I want are the IUPAC name and the common name. For me, they will be both correct, whether you use the common designation or the IUPAC designation. Okay. I'm not sure if I asked you to pause and name this. Go ahead and pause. Okay, welcome back. Over here, if I number it from left to right, I get a substituent at 3 and 5. If I number this chain from right to left, I get a substituent at 1, 2, 3, 4, and 6. You're going with the winner, And again, you only look at the first substituent and only go to the second if it's a tie. Winner. One. I already messed up. 1, 2, 3, 4, 5, 6, 7, 8. Octane. With nomenclature, I'm always worried that there's so many places to make a mistake that I don't skip any of these tips when I name molecules. So I circle the substituents. We have a methyl and tert-butyl. Let's go with the common first. Ooh, we have to alphabetize. We have a methyl, tert-butyl. But again, if your prefix is followed by hyphen, you go by the root. So we go by B. The common name would be 5-tert-butyl. Okay, so this is the one case where you have a hyphen between letters instead of between letter and number. 5-tert-butyl, 3-methyl octane. And when I grade the exams, I'm making sure that they use the correct alphabetizing. B, then M. What does the IUPAC mean? Because we're going to use now these names that are in parentheses. Okay. You notice that if I could have a really complex branching, you should be able to name it by IUPAC following these rules, okay, or these steps. Okay. The common names, you have to just literally memorize them. Okay. So what if I had isopentyl or some other kind of complicated branch substituent? Okay. Because you don't have those names to memorize and I'm not giving you those names, you could always fall back to your IUPAC naming. Okay. The tert-butyl group is 1,1-dimethyl ethyl. Okay. But can we do that from scratch? There's, let me use, I don't know if you could tell color, my computer isn't that great. 1, 2. And then my mini substituents, my branches off of the branch, 2 methyl groups. Oh, how do I alphabetize now? Oh man. I put myself in a corner because I do have a methyl group here, M, but now what do I use for this name? You ignore the Greek. You ignore the Greek, so you have here M. Let me underline the other ones also. Oh man. So I have a plain methyl right here, methyl, and I have methyl ethyl. Okay. I ignore the di in alphabetizing. So in a dictionary, what comes first? It's the one that's shorter, right? Yeah, methyl would come before methyl ethyl. A little bit complicated, but what's also going to look a little strange at first is that we're using parentheses now, because that, oh no, the methyl comes first. Oh man, so many pitfalls. 3-methyl, alphabetizing based off of M. And then we use parentheses. Dash, because we have a number first. And that, see, that 5 is not part of the group. The group is tert-butyl or 1,1-dimethyl ethyl. But it's on carbon number 5. So the 5 is outside the parentheses. And then we have 1,1-dimethyl ethyl. And try to write your name all on one line. Okay. Try not to start at a second line. Now, does this make sense? Because here we said these are equivalent. This is equivalent. Isobutyl, 2-methylpropyl. Isopropyl, 1-methyl ethyl. So we're writing the equivalent but in IUPAC fashion. That 1-methyl-diethyl, that thing right there, in parentheses, is the same as tert-butyl. So all the other components are, you have to show outside the parentheses. The 5, the 3-methyl, okay, and the octane. It's just that because of alphabetizing, now the 3-methyl comes first. A little bit tricky, but those are the two names for this molecule here. Okay. In the final 9 to 10 minutes, I just have actually only 3 more practice problems to do that we could do together. I'm going to draw all 3 of these, and then you can pause the video, copy the structures, and name them. And I don't mind if you use the common name or the IUPAC name for those branch substituents. Okay. Yeah, let's do that. It's a cycloalkane. I'll give you another cycloalkane, but this is going to be cyclohexane. You could probably anticipate that I'm giving you these because I'm wondering how you're going to number the ring. And then the last one, 8 carbons. Okay. You're going to name these molecules, and then when you come back, I'll show you how I would name them and the work I would do to name them. Go ahead and pause the video. Okay, this one here, it's going to be, the substituents are going to be at 1, 2, and 3. And honestly, it doesn't matter whether you count them 1 here and then go counterclockwise, 1, 2, 3, or if you go 1, 2, 3. And it doesn't matter because either way, carbon number 1 is a methyl group. So we can't even use the alphabet to decide which direction, because either direction works. You have a substituents on 1, 2, and 3, and the first substituent is always going to be methyl, the second is always going to be ethyl, and the third is always going to be methyl. Okay. I'm just going to go ahead and go this direction, 1, 2, 3, 4, 5. Okay. No shortcuts, circular substituents. Right after I said no shortcut, I tried to do a shortcut. We're supposed to alphabetize based on the M, so actually the ethyl group comes first. Okay. I'm not going to erase it or white it out. That's going to remind me again not to take any shortcuts. 2 ethyl, 1, 3 dimethyl. Don't forget the cyclopentane. I'm not sure why, but that's a common mistake, that people are so concerned about their substituents and the numbering and the alphabetizing that they tend to forget the cyclo. So the parent is cyclopentane. The numbering on this molecule is tricky. There's supposed to be a substituent in carbon number 1, and we have 3 substituents. We could go 1, 2, 3, 4. We could go 1, 2, 3, 4, 5. That doesn't look right. Or we could even start here as 1. 1, 2, 3, 4. Let me pick one that I think is a good contender. 1, 2, 3, 4, 5, 6. And then maybe on a scratch sheet of paper, if this was an exam, Let me try another way. Let me try 1, 2, 3, 4, whoops, 5, 6. This way, I got a substituent on 1, 3, and 4. 1, 3, 4. On this numbering system, we get 1, 2, and 4. 1, 2, and 4. Alright, so far this is the winner. How do I know that? You're comparing the first substituent. It's a tie. You compare the second. 2 beats 3. Now, I'm concerned, is there another 1, 2, 4 numbering that I missed? Well, if I start 1 here, it would be 1, 2, okay, 3, 4, 5. So if I start 1 here, it would be 1, 2, and 5, which is not better than 1, 2, 4. Okay, this is the winner. Okay. If you don't see that, redraw the molecule and start numbering here, 1. Now, hopefully by now, you know which way to number it, clockwise or counterclockwise, based on getting that second substituent as the lowest number as possible. So if I number this 1, which I did, 2 is not to the right, right? 2 is to the left to get the second substituent as lowest number as possible. Alphabetize. Okay, I remember to alphabetize, and we have a methyl, ethyl, and this guy up here is a butyl. 4 carbons, butyl. B comes first. 4 butyl. I feel like I'm going to run out of room. 1 ethyl. 2 methyl. Cyclohexane. When I'm grading, make sure everything's alphabetized properly. Make sure the parent is correct, cyclohexane. Okay, and the numbering is correct. Last example. Okay, we'll get this under the gun. If I number it 1, 2, 3, 4, 5, 6, 7, 8, my substituents are where? 4, 5, and 5. We have 3 substituents. You would want to see 3 numbers. Now again, I'm not sure why this is a common error, but doing this, that's not the substituent, okay? Right? Because they're not even connected to each other. They are coming from the same carbon, but these are 2 separate substituents. Okay. So I made that mistake on purpose. Don't do that mistake. If I number it, this is going from what? Left to right. If I number it from right to left, interesting. 1, 2, 3, 4, 5. And we have 2 methyls at 4. So this would be 4, 4, 5. The winner is this one. I'm good to make it under 30 minutes. 4, 4, 5. Tri, methyl. They're all methyl groups. Okay, I made that mistake on purpose, but I should have circled these 2 separately. Trimethyl octane. Okay. Alright. The videos that I have currently up with nomenclature of alkanes, those are the 3 that I'm happy with. So that's it for nomenclature of alkanes. Unit 1 is also conformations. So the next couple of videos for this Unit 1, we're going to focus on conformations. And, well, I'll explain what those are next time.